Hello, I'm back. We're gonna actually get some work done on these wheels this time. Yesterday kind of just went over how I built the file, and just rendered a little image of the wheels. Today, hopefully, we can actually get some stuff done. I got some notes on what I need to get done. Let me just make sure the stream is running. Got the synthwave radio from Lofi Girl on because it appears that's about the only decent royalty-free music I have access to, so hopefully you guys like that. Okay, sorry, I'm just making sure things are running. Okay, we are going. Sweet. Okay. Alright, so here is the wheel that I was showing off yesterday. I talked to the client and he said that if you were going to run these on his car, which he's going to be trying to sell them to others, but at the moment I'll just kind of build it towards the specs of his car just to start. Right now they're 18-inch step lip meaning you can see there's this step inwards on the front, which is like visible in this example on the right here. This is actually the client's old wheels that I also designed, and that's what I'm basing these star wheels off of. He really liked the heart wheels that I had done, and this was done like half a decade ago, but he really liked the heart wheels that I had done, and wanted me to do those but with the stars instead. So first step here is going to be to update these 18-inch hoops to 19-inch. So we're going to go into that sketch, and you can see this is a sketch sent to me by the manufacturer that shows their files for the forgings. And then here's my sketch file actually. And should be as easy as moving it outwards by half an inch, since moving it out half an inch on here will increase the radius by half an inch and the diameter by a full inch, making it 19 inches. Boom. Okay. There we go. Bam. Alright. The other thing that needs to be adjusted is the holes for the hardware. So we'll just add an inch to that as well. And we are set. So I'm going to save that as new so I don't save over. And update that to a 19-inch by 10 inches, 30 or 3.5 inch lip. Sorry, just checking to make sure stream is running, because I don't know what I'm doing. To a 19-inch by 10 inches. That's okay. Cool. We're good. We're so back. Okay, 19 inches. Bam. So now you can see we got the 19-inch hoops in there, and the face doesn't really fit anymore because it was designed for 18 inches. Boom. So we're gonna make some adjustments, and let's see. start back at the beginning here so that I can go down the feature tree and 17. Oh, all right. And I think what we're gonna do is actually move to a new forging because he wanted the spokes to float. So like in this, you could see how the actual top visible face of the spoke is kind of floating above that outer hardware circle, giving it the effect that like those hearts in this case, but in the new updated wheels case, they'll be stars, giving it the look that those are kind of floating, and they match up nicely with the step in the case of this wheel, but depending on the sizing of the wheels when people order them, that may not be the case. The face would have to be like adjusted per build to match the lips, and not sure that that's really plausible, but it could be possible if it was like a really fancy show build and the client wanted the wheels to be like absolutely perfect. It would be possible. I'll just keep these here. This is again another example of some wheels that I have designed in the past on the actual car. This was actually one of the most popular wheels I've designed. The hearts kind of started a trend in the wheel industry of heart wheels, and Heritage Forged and a couple other companies even made like heart wheels after these ones, kind of because I started the hype. So that's kind of a fun little history fact for me. But so we're gonna bring in a new forging blank. And I'm gonna bring in a drawing from the manufacturing facility. Boom. So there's that. These are basically the cross sections of the forgings that are available to me at the manufacturing facility. And so I have to design my wheels to fit within these. And I'm trying to avoid using these bottom three because I don't know for sure, but they do look like they are considerably larger in terms of volume of metal. So I'm going to assume that those are more expensive and would bring the price of the wheels up. And the wheels are already quite expensive. So I'm going to try and stick with these top two in the interest of saving money. All right, so let's bring that in. And of course, it's going to come in at an angle because Solidworks never makes anything easy. And we'll just get rid of this, clean up leave up some space here. And beep, 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 beep. 90 degrees, there's that. Okay. Let's see, I'm gonna assume that this is just the space. That's so weird. I don't know why they gave me, I don't know why that's off, to be honest. If that's like an error in their file, like, it's kind of off from that center line on the other forged blanks. 'Cause like that, the other ones, the center line was right here, and that's 0.02 inches away, but in machining that is a non-zero amount. So I don't know. Let's see. What we're gonna do is we're just gonna call it like that, and that works. If that doesn't work, then I will cry. Okay. Now, I'm wondering why this is not showing as a solid shape. So in SolidWorks, if a form is like a sealed complete sketch, you could see that the center of this is like dark. This is not. I'm not really sure where the gap is. Sometimes they're like tiny little gaps that like essentially don't exist, but the software finds it. 'Cause, yeah, oh no. Yeah, who knows? Alright, so you could see, let's see, move. You can see that this will leave a bit more space for verticality on that outer part of the wheel. So that'll give me more room to do that like floating spoke effect that the customer wanted. I don't really want to put this over the top of this other body. So here's what we're gonna do. We're gonna take all this stuff. We're gonna mirror that about this, just so we can keep those lines. And then we're gonna delete this side. Bam. It's gonna get real sad. And we're gonna break the whole file. That's what's gonna happen here. SolidWorks gets really pissy. Here comes the second half of the title of my stream, which is me getting mad at SolidWorks. Because it's a shit program, to be honest. It is the industry standard, but like it's a barely functioning piece of software as far as I can tell. Okay, move. Bam, would you look at that? That's gonna go like that. Okay, let's see, and everything's gonna break. Yeah, so see, this is not a clickable. Oh, wait, there it is. I lied. For fun. All right, so now we have that forged blank. But because it's a new body, okay. All right. All right, so you can see because I deleted that other thing, it's gonna like lose a bunch of these reference points that these sketches had, and so SolidWorks is going to be really angry for a little while at me, and it's going to throw a little fit, and everything is going to be highlighted in orange and red because it sucks. Let's see. Let's see. Let's move that out. 5.5. All right. All right. So, oh, there's one more yellow little angry dot because it somehow. This is when SolidWorks is just stupid for no reason. So like I deleted that other kind of that body, if you will, and created that new blank, but then SolidWorks loses its like connection to this origin point, which was never changed in the first place, but it just does that for the love of the game. Boom. All right, so now we got that. And yeah, so now I have to kind of go into like each sketch down this line and get rid of all these little fucking things here. The little angry yellow points. And we're gonna just make these just related to themselves. Just so that it doesn't get pissed again. Because fool me once, shame on you. Fool me twice. Fool me once, you can't fool me again. As our favorite painter and war criminal once said. Okay. Hopefully you guys like the music, background music. I'm still not sure if it'd be better if I keep the background music or if I leave it blank so that you guys can choose your own music to accompany, since I can't play real music for fear of Daddy YouTube nuking me into oblivion. Alright, so we gotta kind of like make all this stuff a little bit bigger. Since I moved from an 18-inch to a 19-inch wheel, everything's gotta get a little bigger. Let's see. So this is just kind of like trial and error at this point, just adjusting stuff. Normally, if you're building things for manufacturing, like you want to constrain all your sketches and you want everything to be nice even numbers. You want all your sketches to be constrained and you don't want to just be like dragging stuff around arbitrarily. But with the wheels, it's more of like an art thing than design. I don't know. It's more art than engineering, let's say. So like once I get the whole visuals of this thing down, I could then go back in and kind of change everything to even numbers, but I'm not going to do that, probably, because the manufacturer's going to charge me the same amount of money anyways. And toolpathing is like half just the software doing it. So if there's some weird numbers, then the software can figure it out. Sorry to any CNC machine operators who ever watch this. I am deeply apologetic for my transgressions. Okay, alright. So we got our star-shaped spokes. So we gotta get that like floating spoke effect in here. These forgings are weird. I wish they wouldn't like go convex like that. It's kind of obnoxious. It's like this is getting probably too close for comfort. Because they want everything to be 0.075 inches from the edges, from all the edges, just to give the machinist some leeway when they're making stuff, since like these things aren't like perfect down to the millimeter. I know I'm like jumping between inches and millimeters, but okay, what do we do here? I know I'm like jumping between inches and millimeters, but stream up in case someone comes in and wants to say something. I don't want to miss it. Alright, so we got chat and we got chat. Just to be sure. Okay. See, now we're gonna have to like change a bunch of stuff. You know. We're gonna go back a bit to change the actual original sketch a bit so we have more room. Bring that down there. Bam. Okay. I feel like this stream is just gonna reveal how bad of an industrial designer I am. Alright, so we can kind of like, sometimes when I'm doing this, I like to kind of operate off of this line, but I don't know about that. So I think, let's see how that would look. Co-radio, yeah, cause see that comes down and that doesn't look good. Alright, we're just gonna do this in a more simple way because this is like kind of just a decorative little doohickey. So we're gonna just do that. See what it looks like. Kind of do a lot of like trial and error when it comes to this. Some other designers, other CAD people would probably be horrified by how I do stuff. But whatever. Okay, we're just gonna go straight down, offset from surface, this, and then like, I'm trying to remember the amount of depth I need for the hardware. I'm just gonna do 1 inch. Oh. And we're gonna delete that. Bam. Alright, so now we kind of have a thingy. Alright. Let's hide this for a minute. Alright, we're gonna go back through. Of course, it's gonna do funky stuff. Oh, this body wasn't there before. Bam. Alright, so now that looks like shit. Honestly. Not great. So we kind of have that floating spoke situation, but like kind of doing this just kind of by the seat of my pants today, but yeah, it kind of just doesn't look great. Okay. Let's look at the other wheel that I had made and see how much room I left for hardware. Okay, so here's a completed wheel that was sent off and actually made. If you were part of the 0 people who watched yesterday or came and looked at my video after the fact, you'll recognize this from the image I had in the side here on that day. But we're just gonna bring this file in just to see how much room I left for hardware. Because if you're forgetful like me, you gotta always look back and just see. Okay, so I left 0.48 inches for threads. I have these little fungal gnats that are living in some of my apartment plants. So if I'm like swinging my arms through the air like a crazy person, it's probably because of that. I just put poison and stuff in the soil and do all these things and nothing seems to come of it. Okay, so that's 0.55. All right. Bam, 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 bam. You know what? I'm gonna do something else for this. I want to have more freedom to adjust stuff. Alright. 0.25, 0.29. Sure. Alright. Kinda works. Kinda works. Sometimes if I am kind of stumped for an idea, I have a folder, like a folder of bookmarked things on Instagram that are kind of like wheel inspiration. And so I'll look at that just to get some ideas and see. And these are things that I saw on the internet that I really liked, and sometimes I'll kind of refer back just to see like how other wheels that I liked have like dealt with some issues that I am dealing with. And right now I am unsure how to deal with this kind of outer bolt circle area and like how it relates to these strut pieces that come up to my stars. That's insane. Just forgot that thing again. Okay. Alright, yeah, and you gotta figure out something cool. Alright, so let's go back to our inspirations folder and see what we can find. There's a couple companies that like I just really like how they do stuff. One of them is Brixton Forged. I feel like they do a lot of like pretty much just exclusively wheels for rich fail sons whose daddy bought them a Lamborghini, and then they want to get like, they want their Lamborghini to be unique, and so they spend 10 grand or 20 grand on a set of wheels. But because of that, their designers are really good at what they do. Strangely, when you sell $10,000-$20,000 sets of wheels, you have money for really great design. Okay, lots of just pictures of cars. Man, they don't have any close-ups of their wheels for me to spy on. That wasn't worth it. Okay. And like none of these are all great and wonderful, but none of them have that floating spoke design feature that I'm looking. Okay, so here we go. Okay, so they kind of have a little step down, and then that strut is attached to this inner raised section. That's pretty cool. Because it adds like a little design feature on that outside ring area. That's not what I'm looking for. Seems to be how a lot of these companies are doing it, with this raised inner kind of feature that the struts, I'm calling them, come out from. Another one. Let's see. Nope, that's a different type of spoke altogether. Yep, it's the same. See, that looks cool because like it's a little bit more sculpted. Yeah, see, okay, this is exactly what I'm looking at. And they've done what I like to do, which I might adjust the bottom of the profile, is you can see that this line continues through past this strut. So I really like how they did that. So we're going to use that as inspiration. It's not copying, it's inspiration. Man. I do wish that I could just have the image and not the rest of the bullshit. There we go. You can see they even have their little kind of like logo situation on that outer ring. That's pretty sweet. Alright, so I'm just gonna put this over here. Sorry, Lo-Fi, we're gonna cover you up for a minute, but we are listening to Lofi Girl on YouTube. They let streamers listen to their music, so that's pretty nice of them. And it is real music, not made by AI, which is also pretty awesome. Because I have a feeling that a lot of the royalty-free music these days is probably AI generated. Alright. And it's off of my AI, anti-AI soapbox. Oop, that's not the sketch. These are not the sketches you are looking for. Edit sketch. Okay, there we go. All right. All right, so we're gonna just both of these, because if I remember correctly, that was not really, I was running into that forging a bit. So let's show that sketch. Yeah, you can see here's the edge of the forging, and then here's this, and we want to leave more leeway for the machinists and for the machining process, just to make sure that there's no issues. And this, once we make this less curved, I tend to like curves because it looks nice, looks more complex. But if we make that less curved, we can raise the outside up a bit, which will make it more dramatic. And I have a feeling that more drama is what this person wants. Okay. Da, 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 da. All right, so now let's see. See, it's still gonna be real low. Tangent, and we want it to be co-radial, so it'll be the same curve on the outside here. You can see that kind of looks like shit. So we're gonna try and kind of steer that curve up a bit. And so we have to go back to this sketch. Okay, it's getting better, Let's try a bit more. See, if I go too much farther, it's gonna kind of disrupt how the rest of the wheel looks. So we might have to not do this. Go this way. Looks pretty good, but it's kind of chunking. You see there's a lot of kind of just trial and error, at least with my process. I think how a lot of people use 3D CAD software is they're trying to define every sketch and make everything very simple, and that is great. Like, that is what you should be doing. But when you're creating essentially art, you gotta kind of like break the rules a little bit, and so that's what we're gonna do. Alright, so that looks pretty good like that. It's all got all the drama. And then I'm just gonna another little cheat thing. If there are like little things like this, so basically like when we came through and we did this revolved cut to get this profile back into that star shape, there were some little bits that didn't get cut, and so this surface is not flat because there's these old bits. And you can cheat in Solidworks, and you can just select the face, right click, and go not the delete up here. Yeah, so here, let me do it again so I can, sorry, I'm just over and over again. Okay, so if you right click, you can see that red delete, that's the wrong delete. You have to hit the two arrows and then go to the delete with the little kind of box with the face highlighted, because we're going to delete that face. Bam. And there we go. Now that follows the rest of the face. So that's gonna look real nice. Bam, there we go. I don't know why this is mad. Please select, yeah, buddy. Sure thing. Direction. There we go. That's not mad. Okay, so, and of course, it's just gonna kind of forget. Oh, this is a different thing. All right, so. So now we're stuck again, trying to think of how best to treat this this junction of these. That. Okay, what's our... Okay. We could do that. I do kind of like this synthwave one better than the regular like study chill beats, hip hop beats, lo-fi. I feel like that one's more kind of just wants to put me to sleep, whereas this one's got me like hyped to get stuff done. Okay. It's gonna get mad again, because it always gets mad. Okay, so it's going to... And we've got to select the face. Bam. Alright. Look at that. Look at that. Okay, why is this one mad, too? This circle wasn't even like... Oh, see, yeah, this is the silliness. Solidworks just being neurotic. So again, for some reason, because I was editing and other stuff and removed other bodies, and it kind of like lost some of its, the sketches lost some of the relations to other sketches. For some reason, this sketch lost its relation to the origin, which was never changed. But it's Solidworks, so it's gonna do dumb shit. Wouldn't that be funny if Solidworks eventually sponsored me? Then I had to like shut up with all my slander. I'd have to be like, oh, Solidworks is the best software ever. It's so good. Oh my gosh. I've never used software as good as Solidworks. Solidworks never ever has a problem. Oh, you know what we haven't done in a little while? Let's save. Let us save. So we're gonna do this as 3 because I changed it from an 18-inch face to a 19-inch face. So we're gonna save that. And we're gonna, while we're at it, we're gonna save. Okay, so now you can see it's very incomplete, but it at least sits on the barrel, right? But yeah, oh, yep. Save as new. Okay. Bam. All right. And then, again, just forgetting everything here. It's really hard for Solidworks to remember anything. Yep. Alright, so we're still kind of like, oh, what is that? That's gonna go away, I think. So we're probably gonna have to like redo a bunch of these fillets or fillets as they're supposed to be called. Fillet is what you eat. Okay, where's the problem, officer? Alright, just gonna go in circles again. Yeah, I don't really know why that's yellow, to be honest. There's one tiny, I wonder if it's the origin again. Yup. It forgot where the origin was, which has never once been moved. In fact, I don't really even know how to move it. What the fuck is that? Yes, I know. So many errors. Things are just so terrifying for software like you. I'm unsure where these little snippets came from. Ah. There it was. Boop. Alright, so now we have our floating spoke. Got that. This might not work, but we're gonna. Uh-oh. Okay. We're back. We're so back. Okay. Okay, so now is the kind of making it look good situation. We're gonna add fillets, we're gonna smooth stuff out, we're gonna make it sexy. And this is like looks like an undercut. Like if you're thinking in like a traditional machining kind of situation. But they can do this kind of thing because the first step in the like machining process is they stick that like forging blank on an industrial lathe, and so they can kind of lathe out this profile, and so it's not cut from the top like the rest of it is. So they can do an undercut that's part of the basic outer profile of the wheel. Alright, so now we're gonna make some more design choices. And I kind of like this big kind of rounded slopes. I feel like that just looks good. And then we're gonna kind of align the top of these fillets up. Oh, so that looks good. That's pretty dang sweet. Alright, so we're gonna keep going down the feature tree and see if anything else has broken from me messing around, changing the like size of the wheel. And so far everything looks pretty good. This center area is a little questionable. I don't like when there's so many kind of surfaces meeting each other in one small area, because like the curves and transitions can end up looking messy. But at the moment, we're gonna keep this like it is and see. Ooh, that's interesting. It's kind of cool. All right, again, it's adding more curves, so it might get axed later, but let's see what it looks like. Here we go. Okay. Not bad. And I do like on this wheel this little cut that they added, so I might steal that. I think when it comes to wheel design, every single wheel, for the most part, is a copy of a copy of a copy with like small changes. I feel like the reason that like my wheels have been so popular when they have kind of blown up is because they're generally not a copy of a copy of a copy. They're generally like unique. Like you can see like this star wheel, it's kind of a gimmick to some people. Like some purists might consider this a gimmick, but I mean, it's always nice to see people having creative freedom when they're creating something, and like building a car is creating something. So it's nice to have different stuff, because if everyone had the same simple 5-spoke wheel, if everyone put TE37s on their car, which is like one of the most popular styles of wheel, it'd be boring. Yeah, I lost that relation to the center there, so we're gonna put that there, make that for construction, make that co-linear. But along with that, going off that, like, wheels are being copied, and I try to not copy so much. Like, I think it's perfectly fine to kind of like use features that you like on other designs. That's used in art and design and music and stuff. And so don't be scared to kind of copy a little bit. Offset from surface. 0.8. What's that gonna look? Okay, so that's 0.8. 0.7. 0.65. Alright, so we got that cut. Alright. Well, alright. That's pretty cool. And we'll, 0.25. Let's keep that a nominal thing so that they can use a 2.5 or a 2.5. A half-inch mill end, half-inch diameter mill. Rounded end mill on that, because I'll just Every once in a while, I like to be nice to machinist. Not very often, though. Bam! That's another little kind of time saver is you can just do it on one side and then mirror it. Boom, boom, boom. So now we have that little cut on both sides. That looks pretty dang good. Pretty good. Nice. I think one thing we forgot is this is they have some real sharp edges on those. What is this? 0.1. Let's 0.0625. And then let's see what this. Oh, it don't like that. Okay. Interesting. Is it that? Okay, here's what we're gonna do. Delete, boom. Another little cheating there, doing the cheat thing. Alright, nice and rounded. Because again, like I said yesterday, you don't want to leave anything unfilleted or sharp, unaddressed, any edge or corner unaddressed, because if you don't address it, the machinist will, and then choices are being made that aren't yours on your product. And that's not great. Boom, 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 boom. Look at that. Okay, so that's pretty dang cool. Let's see how that looks on here. And that's really far up, and we want that to be farther down here. So I am going to actually change. Ooh, just kidding. Okay, first let's measure this point to this point. That's alright, so what if we just do like a 4-inch lip? Let's try that. Yep. Alright, so let's open up this hoop file. And we are going to make a 4-inch lip version of this file. So we're gonna move this up by 1/2 inch. So now we have a 4-inch lip instead of a 3.5-inch lip. Just kind of adjust all these other little, and it's a bunch of this stuff looks kind of useless, but this is all very useful for measuring and getting the offset. So right here you can see that is 4 inches. And the back is 7 inches. But the actual width of the wheel is measured from this point, which is essentially like where the tire meets. Because when you mount the tire, the edge of the tire, the bead of the tire is going to be right in here. And so this outer lip point is not really important in terms of like the actual mounting of tires. And so when you get, like, you could see this is 3.5 and this is 6.5. So when you add that together, that equals 10. So this is a 10-inch wheel as measured from where the tire sits. But it is a 4-inch lip when you measure it to the outside here. So this is a nice little 1/2 inch. But okay, so now we have a 19 by 10 with a 4-inch lip. So we're gonna save this as new so we can use this later. And we don't have to do that again. 19 by 10, 4, save. Bam, so there we got that. Okay, so I don't know where this... Bruh. Okay, so that's looking pretty good. I like that. I don't know. What the fuck? I don't understand why Solidworks is going into lightweight mode or whatever that shit is. That's really unpleasant. Okay. And then I'm curious what this is going to look like with exposed hardware. So we're going to add that in because I think that would be fun. Let me look at the new wheels that I got and see what kind of hardware they're using. Okay, so they are using these big ones that have the little skirt around them versus these nice little tiny hardwares. So we're gonna need to make big okay, alright, okay. Extruded cut. Offset from surface, and the surface we're going to offset from is that, and we're gonna do it 0.55. Bam. Wow, would you look at that? It's already set up. God damn. Alright, so this is where the hardware goes. That's pretty sweet, but I don't really like how this curve is interacting with that. What if, bear with me here, this could look terrible. What if we only showed the 2 bolts in between each star? That's kind of fun. Let's see what that does to the overall design. Boom, boom, boom. And see, then that leaves this spot open for text, which I love adding to wheels. You can see, I'll bring up this one again. I love adding text around the outside. The resolution's not amazing, but you can see here I've got Idle Night, which is my brand name, and then MMXXV, which is 2025. And then down here I have 6061 or no, actually up here I have 6061 on this side over here, and then here it says Racing Spirit Forever, which is just kind of fun little phrase that I put on there. And then having them dated is kind of fun because these are like a one-of-one wheel. No other wheels will ever look like this, so it's cool that they have a date on them too, because that just kind of like sets that in stone of like when those were designed and made, and it gives them the customer that extra little personal touch, which is nice. Again, well, ooh, let's not do that. You know, I'm just gonna leave those sharp. I know I said don't ever leave anything sharp, but where's your lug? I kind of usually leave the stuff around the lug sharp, because since that's where hardware goes in, that's one time when I do defer to the machinist, because they are more experienced with that kind of stuff than me. And then I am worried. Well, we'll see. This might be good. I'll verify that later. Alright, so we got this, and then we got our assembly. And it's gone sad and forgot some stuff. Solidworks does that. Alright, so we have our wheel now, and I've already got some hardware. Oh wow, that's awesome. It's just, I'm not gonna read that at all. Okay. All right. So we got our hardware. It's gonna sit right in there. And instead of just kind of putting in 10 different hardware bits, we're gonna do a radial or circular pattern. Just choose any circular face so that it knows how to revolve that. And there are 40 holes or 40 pieces of hardware, but we're only showing 10 of those. So we're gonna select the instances we want to skip. All of those. That's fun. All right, bam! Look at that. Would you look at that? That's pretty sweet. All right. Alright, well, let's do a render of that, and then we probably have time for like one other silly little project. Or wait, let's use the export. Export as step file. Stream documents. 3. Oh, and this background is a modified car by Kaiza, or the Kaiza on Instagram. He's like one of the most famous car kind of modeling dudes. He started off just using Photoshop to modify cars, and then learned how to model, and now has released a couple body kits, and he's really well known. So he's like a big inspiration to me, and plenty of other automotive related designers. Just a little shout out for that, since you guys will probably see this wallpaper quite a bit. And I didn't save that last scene we did last time because I figured people could watch me build it again, because it's kind of fun. If I was like on the clock for someone, I would obviously like save my thing or my scene and not rebuild it each time, but for this stream, I think just building that thing again will be fun, because then anyone who watches this video and doesn't watch the last video will still get the knowledge of how to set that up. Okay. So here is our wheel. Make sure to set it to GPU rendering, unless for some reason you don't have a decent GPU at all. Because like even like a 2 gigabyte card or a 6, I guess that's probably no one has those anymore, but even like a 6 gigabyte card is gonna render so much faster than your CPU. Yeah, so we're gonna just start by putting those materials in there again. And there is like a chrome material, but I have my own kind of polished aluminum material, just because the chrome one is like a mirror, and it doesn't look good in the renders, whereas this looks a little bit more, you can kind of see what's happening. It looks better in my opinion. Then the hardware, we're gonna just do black hardware, maybe. For these renders, I do like to choose very basic finishes, especially, I mean, for the initial renders that I send to clients, and that's so that they're not distracted by, like, let's say I do the wheel in pink and they don't like pink because they're a big, strong, manly man, and pink offends their sensibilities. So they don't like the design because it's pink and not because they didn't like the design. But if it's in just like a general silver color, then they can't complain about the color. I am going to stick to that gold center cap because it's, at the moment, let's say that's kind of like this standard. I've only gotten one of these center caps made, but we'll see that gold. We'll say that gold will be the standard available finish. So there, we made our metallic gold. Bring in our little carbon fiber puck here. Our white lettering, and I will probably be changing my center cap design. But at the moment, that's what it is. Alrighty. Alright, let's get rid of this thing. So you can see that little twink playing on his computer there. You know, black hardware is too overbearing. There's so many complicated, or it's just the basic polish. There we go. So shiny, and then nothing's ever perfect, so we're gonna take that roughness down a tiny bit. And there's that. Looks pretty good. So we're gonna make another scene. This time I'm going to defy gravity. We're gonna have the wheel kind of floating like this. And then we're gonna add in some lighting again. So we're gonna bring in some discs that will essentially just be giant soft boxes. What's going on here? I think occasionally the computer gets mad that I'm streaming and rendering and doing all this stuff at the same time, and just it's that flickering probably. Alright, so we got a disc there. Duplicate that. Move it over here. And we're gonna kind of put that in a different spot just so that I like some variation in my lighting, because like nothing's ever perfect. And I think that's a big thing in rendering, is you always want to have some imperfection to make things look real. Alright, so we got these two discs that are illuminating our environment. Let's add a ground plane so that you can see that the wheel is magically hovering. There we go. That's pretty sweet, but these are both too dim. So we got that, and then let's add a spotlight as well. Oh, that's pretty sweet. That's pretty cool. Kind of like that shadow under it. That's just fun. And then, oh yeah, like we did last time, we don't really want these discs visible to the camera, because in real life you'd see the soft boxes, but this isn't real life, so we can just hide those. Where'd my spotlight go? Excuse me? The fuck? Awesome. Just forgot that it was there. Dude, what is going on with this task? Not quite sure what that flickering is. It is super obnoxious though. Ground material. So we're just gonna make the ground black. Oh. Basically, I don't want to see that line in the back here. Because you can see, like, if I turn it white, you can see there's a line where you can see the edge of that ground plane. And I could extend the ground plane out, but I don't know. I'm lazy. You know. Alright, we're gonna do that anyways, though. Ground plane. Size. 4. Boom. Get out of there. Get out of there. Okay. So now you won't notice the edge of the ground plane there. We got our cool wheel floating in space magically. We got those lights hitting it. It's shiny as fuck. And again, I set the focus to my logo because I'm selfish. And then we're gonna bring the depth of field, the f-stop, up, I guess, in number, not open, because open would be a lower number. Boom, and that's just to kind of make some part of it start to get blurry so it looks like a photo. Because if not, then it looks fake. And this is a real wheel. Okay, that looks pretty sweet like that. We're gonna do that same thing we did last time and add the particles in the air. Boom. Yo, that thing's huge. That's all. What the heck? Why is that cylinder? Okay. Okay, sweet. Alright, so we got our giant cylinder, and we're gonna put a scattering medium on there, the fog. Go back to our camera. Reduce the density way down, because we don't want like smoke or fog, we just want particles in the air. I'll kind of tint them warm because this will kind of help warm up the image a little bit. It's nice. And it turned off GPU again. Awesome. Boom. Oh, it's pretty good. Oh, I forgot this back. This thing that should be black. Oh, there you go. Looks pretty damn good. Although, I'm gonna change this angle because like I want that hardware to be visible when I send this image to the client. Since that's gonna be a discussion point. So we're gonna have to aim this more at the face, which it's not as good of a picture in my opinion. It's not as dynamic. You could probably like kind of zoom in more, just to kind of, boom, there we go. Camera, boom. There we go, that's nice. And let's see. Okay, the lighting is the last thing. Just boost, crank this way up so that it looks better. It looks more better. And add a little bit of bloom, so that's a fun effect. Looks pretty good. A little bit more of that focus. There we go. That's nice. Alright, so we're gonna, now that it's gonna be running this render for a little bit, because this is the final render for that, so then we can chat about what's next. Let's see, so this week I'm still gonna be doing mostly wheels. Tomorrow I'll probably actually announce that I'm streaming to some friends and stuff, so that maybe people will be watching. And we're gonna start a new wheel, the 3-spoke that I was talking about yesterday. Finish out the week with those wheels, and some unrelated to wheels good news. Second, I did hear back from that company that I am doing the Polaroid thing for, and they said that I can stream that and share the whole process. So that's awesome. I'll tell you guys all about that when I start that process. This is a silly thing I 3D printed, but so here is the camera. This is a Mamiya press, and that is because this was used by people in the press. This was essentially a compact camera, one of the most compact cameras at that time, which is funny. And it was like, you could put different things in the back, so you could use old discontinued peel off Polaroid film, which is like a whole different discussion, or 4x5 sheet film, and you could interchange these back pieces. So you can see on the inside here, yeah, so you can see there is the shutter through there. And it focuses using, by basically just moving the lens forward and back from the film, which is how every lens works, but it's like more obvious how it works for this. But so we've got this. This is a little silly thing that I 3D printed a while ago. That's kind of just like a focus throw handle. If you're into firearms, kind of like those zoom throw handles that people get for their scopes. Yeah, I thought that was kind of fun. But so that's going to be the next big project. And here is that development unit I was sent by this company. And again, I'll tell you about the company and the rest of the stuff when I start that project. But basically, it's got these two little metal rollers that squeegee the development chemicals across the instant film and pops it out like a Polaroid camera. And so I have to... That sound was the sound of the render finishing. I have to design a way for this to interact with this. It's going to be pretty complex. It'll be a lot of fun. It's going to involve a lot of 3D printing. This was the last one I did, and this is just the bottom of a Polaroid camera. You can see there, Polaroid film goes in there. There is just like a battery in here, and I put a mechanical keyboard switch in there, and I don't know. Oh, I have a noise gate, so you can't hear it, but you press the button and it spits the film out. And this attaches to the back of this. Like so. And so bam, now this is a Polaroid camera. But I want to do that with Instax wide, which is a cool format. I think it will fit perfectly because the Instax wide film is the exact size of this space right here. So I think it'll work perfectly with this camera. But yeah, this is all the goodies that was sent. And they gave me permission to stream that process. So that's going to be really fun. It's going to be the next big project. Yeah, yep. Let me put this away. Throw that on the couch for now. So, get hyped for that. Sweet, here's that render. Pretty awesome. I think these wheels are going to be pretty close to done. Going to talk with the client and see what he thinks about the hardware. This might be something he won't like because it is kind of a little weird. See what he thinks about that, and the changes I've made to the design. But that is that. Let's see, what time is it? 4:13. Let's do one silly project before I go. Open Solidworks again. So I have a lot of hair, if you haven't noticed. And one of the irritating things about long curly hair is if you have straight hair, we all kind of shed hair. If you have straight hair, a lot of it just kind of like goes out into the world. With curly hair, it kind of just stays in here. And so when you shower, it just comes out in like fucking handfuls. And it goes down the drain. And you can get one of those little drain filter situations. But the way my drain plug works is it has like a piece that pops up in the middle, and there's no like drain plug. So I want to design and print a thing that can go in my shower that will catch my hair and keep it from going down the drain. I know that's not the most exciting and beautiful thing to create, but that's what we're gonna make. And so I had previously made this beautiful sketch right there, and you can see I kind of roughly drew the drain plug, and I took my calipers, which is pretty much a necessity for any industrial designer and anyone designing anything for manufacturing and anyone who's designing anything for 3D printing. You need calipers, and these are just cheapo ones from Harbor Freight, and I've been using them for probably a decade now, and they still work great. So you don't need to buy the super expensive, super expensive branded stuff. Just go to Harbor Freight and get you some calipers, and then you're a real designer if you got calipers. So I went in and measured the drain plug, and so we're gonna go in on the right plane here, and we're just gonna put in the drain plug. Because it helps to just like have the stuff that you're designing for in your file whenever possible, and it doesn't have to be like beautiful or perfect, but it just has to be dimensionally accurate. And so that drain plug is, oh, and this is the great thing about designing for myself, is I can go back to designing in millimeters, which are infinitely better. So I measured that, and it was 51 millimeters in diameter. So we're gonna do that. There's that. This doesn't matter because that's inside the drain, and it's not really gonna have any bearing on the thing, right? So, and then there's kind of like a little chrome ring around it, and then it comes up and out. Okay, so there is our reference drawing. Or wait, I lied. That is going to be the thing. So that is 70 millimeters. And that, just gonna make that collinear. Boom, boom, boom. Okay, and then it kind of comes up and out. But it was kind of rounded. We're gonna make it rounded, 'cause why not? And again, like, I'm doing this in a way that would offend every one of my design teachers, 'cause you can see when a line is like constrained, it's black. That means it's like defined. And you can see all of these blue lines mean that they are undefined. And so that's bad. But I'm a terrible person. 16 millimeters. Okay. Okay, that's enough of that. See, because I was stubborn and defined stuff, now things are dumb. What's happening? Oh, I just fucking this shit too. Oh, look at that. Alright. Look at that. Alright, so here is our drain. Boom. We're gonna make that a dark color, because it's not what we're printing. All right, so there is our drain. And we need to make some sort of hair drain catch. So let's look at current hair drain catches on the market. Hair catcher. Images. Okay. Alright, so it looks like they just have a bunch of holes or whatnot. I don't like. This looks really. Yeah, that looks really easy to replicate. I don't know if that means that it's going to be worse, but. Alright. Go back to that right plane there and show this sketch and make a new sketch. And this thing is going to sit directly on this surface here. And then maybe kind of come in with some little fingers. Needs to have some space around this. Just 1 millimeter's fine. Here's the vibe. I kind of miss listening to like real music, but this is pretty fun. It's not terrible. Alright, so kind of make this fun little shape there. Alright, so that sets around the drain there. That looks pretty sweet. But how does it grab all the schmutz? Let's see. I kind of want more surface area on the outside to kind of hook and grab and hold hair, I think. I know this is kind of like a gross project, but there's something I needed. Alright, so now those would be kind of like little areas to hold stuff. Alright, and then hide that sketch, show that one. Offset. No, select just that. Alright, so 3D printing. So let's just do a 2 millimeter thick wall. Offset by 2 millimeters. Extruded cut. Alright. Mid-plane. 2 millimeters. If we keep everything 2 millimeters, then it's, I don't know. Oh, it's mad. It's mad. Whatever. Come farther in, because it's leaving little snippets of material. Alright, so bam. Extruded cut. 2 millimeter. Mid plane, so it cuts kind of in the middle there. Boom. Now let us do a circular repeat. Features. Cut. Features. Cut. Thank you. 20. No, that's not. Boom. Alright, that's not enough. Okay. Oh, we cut the drain. We cut the drain. We can't cut the drain. Okay. And like, honestly, that would work. Probably wouldn't cut down on the flow of water too much. Let's double that. And then let's get this down to 40. There, now it shouldn't affect the drainage. And then with 3D printing, like, I don't want to print this with supports because there's like 40 of these holes here, and I don't want to knock 40 supports out. And like, it could get away with printing these bridges, but I'd rather just round these. That's unfortunate. We're gonna do the thing again. Let's see, we're gonna add the fillet to that repeat. Doing it at the bottom too to make it look nice. There's that. And we're gonna add that fillet to that radio repeat. Bang. See, look at that. That looks like a thing. That looks like a thing. What the heck? Then I kind of want to sculpt this, or kind of improve the visuals of this thing a bit, just for my own enjoyment. That's kind of fun. And then we leave those two sharp edges just for fun. Then on the bottom there, kind of round these a little bit. Cool. So hopefully once we bring this back down, everything will work nicely. Bam. All right. So there's our drain couch. And like, this might be annoying to get the hair out, but honestly, I could just be a terrible person and throw it away and print a new one if that's the case. Save to this PC. Stream documents, first stream stuff, and I'll reorganize this later. Drain couch. And we're gonna export as a 3MF file. You can save as an OBJ for 3D printing, but I've started using the 3MF files because the slicing software will actually save like slicing information into that file, which is pretty sweet. So if you can save as 3MF for your files for 3D printing, I would do that. And then Orca Slicer is free open source slicing software that does weird slow motion shit. That has it's improved my printing by my prints by so much. It's honestly night and day. I don't know what I would do without Orca Slicer. Bam! So that's there. Oops. Put that in the very center. We'll just slice it, see what it says. Floating region. Sweet. So this looks like it's going to take about 4 hours to print. So I'll print that probably tomorrow morning. And then when I get on stream tomorrow, I will show you guys the print, but you can see, so this is going to be a little sketchy with these points, but we're just going to print it and see what it looks like. Yeah. So that should keep me from having to take apart my drain every 2 months. And because it's a 3MF file, I can just save it and exit and then come back in and it'll be right there waiting for me. Bring up that render again for this last little goodbye. So here was the render we just did. Looks pretty awesome. Here's the render we did yesterday. Also awesome. Because I'm awesome. And here is the wheel that I designed like 5 or so years ago that this was kind of inspired by. So you can see the original heart wheel. My kind of first idea. And then after talking to the client and him explaining that he wanted this kind of floating spoke face effect, here is, and then here's the updated one. So that's pretty sweet. This is pretty close to being done. It just depends on what the client thinks of this. I'll send the render to him and see what he thinks and let you guys know. I will probably be on tomorrow around the same time, maybe a little bit earlier. But on around the same time, we'll start a whole new wheel, 3 spokes. I'll probably have some sketches ready for the start of stream to show you guys for like some ideas, because like my sketching ability is not great, but just sketching out some ideas and at least having a little bit of an idea for how to do it was a good way to start. Yeah. So I'll be back on tomorrow around like 2 p.m. Mountain Time for the next iteration of, or the next wheel design. I am streaming on YouTube and Twitch under Idle Night TV. You can find my Instagram under the same name. I haven't posted anything on there yet, but I'm waiting for photos of wheels on cars that I have designed recently to start posting on there. I'll start posting some of the stream stuff eventually too. But